Please make sure your lesson printout, your student handout is in front of you as you get started with the video, so that way you can take notes as the video goes. Hello students, the first slide is our warm-up. Please work out the problems, find the missing side length of the right triangle, and then check your answers on the bottom of the page. Today's lesson's essential question is, how can you find the trigonometric function of an acute angle theta? And then your note-taking vocabulary is below, so please read every one of the questions or every one of the vocabulary words. So this is a slide of a core concept which really comes from the vocabulary words that you have read on the previous page. Right triangle definitions of trigonometric functions. Let theta be an acute angle of a right triangle. The 6 trigonometric functions of theta are defined as shown. Sine theta is the opposite side divided by the hypotenuse. Cosine theta is the adjacent side divided by the hypotenuse. Tangent theta is the opposite side divided by the adjacent side. These first 3 trigonometric functions you already have reviewed in the review lesson, in the previous lesson we did. Now the new ones are cosecant theta, which is the hypotenuse divided by the opposite side. Secant theta is the hypotenuse divided by the adjacent side, and cotangent theta is the adjacent side divided by the opposite side. I am sure that you have noticed that the second set of 3 that I just read are reciprocals of the first set of 3. For example, sine is opposite over hypotenuse, and cosecant is hypotenuse over opposite, so those two are reciprocals of one another. Cosine is adjacent over hypotenuse, and secant is the reciprocal hypotenuse over adjacent. And tangent is opposite over adjacent side, and cotangent is the reciprocal, which is adjacent side over opposite side. This is also written for you in the reciprocal notation below. So cosecant theta is 1 over sine, in other words, the reciprocal of the sine function. Secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. This will be very important information for you to know. And every time you're working on these notes, I would like you to flip back to this page if you need any help or to consult this core concept. In our first example, we have to evaluate the 6 trigonometric functions of the angle theta. So the first thing I will do is I will mark angle theta with my arc. And then I decide which side is my hypotenuse, which side is my opposite side to theta, and which side is my adjacent side to theta. So this is my hypotenuse. This here is my opposite side. And here is my adjacent side. Now, once I did that, I can see that I am missing one of the sides for this triangle, but I already know the Pythagorean theorem, so I'm going to have to find the hypotenuse, the length of the hypotenuse. So I'm going to say a squared plus b squared equals c squared, which is your Pythagorean theorem. Side A and B are the legs of the triangle. So A I am going to call 5, so 5 squared plus B is the other leg, which is 12 squared, will equal to C squared. So 25 plus 144 will equal to C squared. That means C squared will equal to 169. And now I need to take the square root of both sides. And finally, I arrive at an answer for C, which is the length of 13 units. So now I can label my hypotenuse as the length of 13 units. So sine, I know by looking at my little acronym. I'm going to say SOHCAHTOA. So the sine is opposite over hypotenuse. So let's go ahead and find the opposite side divided by the hypotenuse. So the opposite of theta is 12 and the hypotenuse is 13. Now I also know that cosecant, which I wrote right next to it to remind you that those two are reciprocals of one another. So cosecant is the reciprocal of sine, so that's going to be 13 over 12. So now I move back to cosine. If you look at cosine, cosine is adjacent over hypotenuse. So I can do cosine. The adjacent side of theta is 5, and the hypotenuse is 13. And again, the reciprocal function is secant, which is going to be 13 over 5. And now I'm going to look at tangent. So tangent is opposite over adjacent. So let's find opposite over adjacent. So the opposite side is 12 and the adjacent side is 5. And then I'm going to look at the reciprocal function, which is cotangent 5 over 12. In example number 2, we are again going to evaluate trigonometric functions. And in this case, we are given a right triangle with angle theta, and we are given the information that sine theta is 4 over 7. Evaluate the other 5 trigonometric functions of theta. So the first thing I will do is I will write down that sine theta is 4 over 7. And I also know that sine is opposite over hypotenuse. So for me to have a clear picture, I am going to draw a triangle and label the triangle. So let's go ahead and draw a right triangle as much as I can. A right triangle. And so now I can go back, label the right angle right here. So I know that the hypotenuse, which is the side opposite the right angle, is going to have a length of 7. And if I label theta for one of my angles, I can put the side opposite to it is 4. So again, what I have is a triangle with one missing side. But because I know it's a right triangle, I can start using the Pythagorean theorem, which is a squared plus b squared equals c squared, to find the third side of the triangle. So I am going to say that A is 4 and 7 is c. So 4 squared plus b squared equals 7 squared. 16 plus b squared will equal to 49. Subtract 16 from both sides so we can solve for b squared. So b squared is going to give me 33. And then I take the square root of both sides. So I know that b side b will have a length of the square root of 33. I'm not going to evaluate the square root of 33. I'm going to leave it as a radical because that is our most accurate answer. So let's move on to the reciprocal function of sine, because we know that sine is 4 over 7. We also know that the reciprocal function is going to be 7 over 4. So now let's move to cosine. So cosine is the adjacent side to theta, which is the square root of 33 divided by the hypotenuse, which is 7. We know that the reciprocal function is going to be secant, so that's 7 over the square root of 33. However, we don't want to have a radical in the denominator, so to rationalize the denominator, I multiply top and bottom by square root 33, and I will get an answer of 7 square root 33 divided by 33. So let's move on to tangent. Tangent is opposite over adjacent. So opposite to theta is 4. Adjacent to theta is the square root of 33. So again, I need to rationalize the denominator. So I'm going to multiply by root 33 over root 33. So the answer for tangent, I'm going to write that underneath here, is going to be 4 times the square root of 33 over 33. So this will be our tangent theta. And last, cotangent theta. So for cotangent theta, I'm going to look at the original ratio of tangent and take the reciprocal. So I'm going to get root 33 over 4. On the next slide, you will have 4 monitoring progress questions to do. So please stop the video right here so you can do the 4 monitoring progress problems before you move on to check your answers. On this slide, we have a core concept about the trigonometric values for special right triangles. The first special right triangle is the 30, 60, 90, and the second is the 45, 45, 90 right triangle. What I'd like you to recall is, which I drew on the bottom, the relationship between the side lengths of a 30, 60, 90 right triangle. So the relationship is the shorter leg is A, the longer leg is root 3 times A, and the hypotenuse is twice A. So if I look at the value of A and I replace the value of A by 1, then I get 1 for the shorter leg, 1 times the square root of 3 for the longer leg, and 2 times 1 or 1 times 2 for the hypotenuse. Similarly, what we looked at before for 45, 45, 90, that the length of the 2 legs are equal, so they are both having a value of A, and the hypotenuse is square root 2 times that value A. Again, if we replace A by 1, we'll get the side length of 1, the side length of 1, and the hypotenuse is 1 times the square root 2. So now if we find the trigonometric ratios of the different angles, we can see that of a 30-degree angle, sine is the opposite. So 30-degree angle, sine is the opposite divided by the hypotenuse, which is 1/2. Cosine is adjacent divided by hypotenuse is root 3 over 2. Tangent is opposite over adjacent, and then rationalizing the denominator, so that's how you get the square root 3 over 3. And cosecant is the reciprocal of sine, secant is the reciprocal of cosine with rationalized denominator, and cotangent is the reciprocal of tangent. Similarly, the whole process goes through 45-degree. Then I will use this triangle, and then for the 60-degree angle, again I go back to my first triangle and write down my trigonometric ratios. This was video part 1, so for the rest of the lesson you will have to move to video part 2.